Okay, I wanted to do another video hoping to offer a better explanation of how I developed this method for cutting angled tenons. I watched my last video and it's a little bit convoluted, I guess is best I can say. So starting back from the beginning of this project, this is my top, 14 inches wide across the top, I call this, and then 12 inches across the bottom with that taper cut on both sides. So I wanted, and I'll turn this around in a minute, I wanted the stretchers that run parallel to this edge, or run on this edge, to be parallel to it. So I had to develop an angled tenon because I did mortise and tenon joints in the legs. So if I turn this around now, let's see, let's just go this way here. So you can see now the angle of this stretcher matches perfectly with the edge of the table, but it meets the leg and keeps the leg at 90 degrees on all four corners. So in order to get that angle, you know, on the table saw, you'd have to figure out what it is exactly, but doing it with my method on the router table, it was slick and easy because the router bit cut these shoulders and tenons at the proper angle. And I'm going to cut another sample tenon here to show you what I mean. But then you can also see that these inside stretchers needed to have that same angle because of the flare that you create here going the other direction, and I needed that to mount the tabletop to these to give it that elevated look. And let me stand this up and show you that. Hang on a second here. And I want to show you these. I want to show you these joints as well, so you can see right here. This would probably be the best one, I guess. That this joint is nice and tight on all four edges because of the way it was cut on the router table. These through tenons and the inside mating surfaces turned out perfect, and all with just a very little effort. You know, a little measuring is pretty much all I had to do, and the equipment and the setup took care of the rest of it. So then you can see the effect I got here with this inside, with these inside stretchers being curved up and offset. Tenon is centered, but the piece is offset up to give you that a raised table look. So looking at that joint, I hope you can see that turned out pretty, this just turned out fantastic. And same with these in here. Let's see if I can slide this over. This joint is nice and tight, and like I said, this thing opened up a whole new possibility as far as angled joinery for me. So let me go and show you the setup that I used to run these joints, and then I also made some improvements to my Tenon Jig, which makes it a lot easier and faster to use. So let's get to that right now. Okay, so here's my setup at the table saw. The one improvement that I made over the last video is this knob right here to lock it down. Before, I was using a quick clamp, and I had to eliminate this stop out of there in order to use a quick clamp to lock it. Now I don't know why I didn't think of this before. Now I've got this knob with the T-nut running through into this extrusion, which looks like this. Let me get my caliper here. This stuff is 80 millimeters by must be 15. Yeah, says 16, but I don't think that that's right. I think it's 15. Yeah, no, 16. Okay, so 16 millimeter by 80 millimeter, and it's just got the two slots in here. But you can see the profile of it there to mount whatever you want to it. So I've got a piece of this mounted to my linear guide rail bearing, and I'll show you some different shots of this before I break away and set it up for the router table. But this gives me the ability now to move this to whatever position I want, lock it nice and quick, and I'm good to go. So my stop here ends up reading 0. I don't know if you can see this or not. Let me just move this over here. Right there, so I'm back to 0. So I set my stop for 0, and then my width of cut, I have to use this little block in here because of the way this is bolted down to my THK bearing rail. So my stop won't slide past those bolts, so I put this in there to cover that, and that gives me my width, and I set my other stop here, which brings it out to there. And that width cut was supposed to be for a 400 thousandths width tenon. With that quick of repeatability, just by loosening the knob, pulling it over, and then locking it back down. So back and forth, and you can see how the gauge is going back to 0 there, and here it's going to I think it's 475 or 575. Sorry, because 400 thousandths for the width of the tenon and 125 thousandths for the width of the blade. Okay, so back and forth like that. That gives me that repeatability for just a standard straight tenon. So let me show you the tenons that I cut last night, because I'm not going to show you how I used it on the table saw today. I'm going to show it on the router. But I cut 4 tenons. They all measured 406. And let me change this back here. There you go, 406 each tenon. So it provided amazing consistency. So I'm 6 thousandths big or fat, which is fine. I can trim that off. I can readjust my my movement here and get the exact width I want to fit whatever mortise I have. So the thing that you have to be aware of when you set this up is going over here, is that This is a piece of our standard 40/80 fence with the bearing rail mounted to it. And it kind of worked out just about perfectly that I could take a piece of Baltic birch, mount it on the top with some screws, or mount it on top of this other piece of aluminum extrusion, 16x80. And then this was a piece of scrap 40x120 that I had given to me that I made my runner out of, and I used our standard THK, or our standard table glides that we sell with our fence. I got a couple of those underneath here, so that works out where that rides on the tabletop. This is square. That's square to the table. I also checked it to make sure that it was running parallel to the miter slot, and that was all I really had to do to get this thing set up. So that's how you would use it, and then this gives you the ability to use these Festool quick clamps to hold your workpiece and your backer board. So I have this is my backer board for my other setup, but that would be mounted on there like that, so that you eliminate tear out on your tenons. So, but if you're going to cut angled tenons on the table saw, I think it would be a lot more difficult to do it. For one reason, you are not going to be able to cut that shoulder. You'd have to still do that by hand, and that's the problem I was having on my table. So now let me show you the setup for the router table. Okay, the router table. I found these two pieces of scrap wood in my pile over there. I don't know why I had this in here. It was a test mortars for something, but I've measured it. It's about 390 thousandths width, and the length I'm not sure what that is. Let me see here. It's got rounded. It's probably about an inch. Yeah, it's a little over an inch before you get to the radiuses. So that's what I'm going to do. I'm going to cut a angled tenon to fit this mortise at this width on my router table. Now the depth, I didn't even measure that, but I set it this way. I just put it over the bit. I have a 3/8 inch bit here. Just dropped it over that. I raised it up until it started to move off the table. So then I just backed it down until I knew I was clear. Well, a little bit more here. There. So I don't bottom out. So that's the height of my depth of cut. And I suppose you could change that up to that. You could keep bringing your bit up and take a lighter cut, but I'm going to take the cut off of the outside edge of this until I reach the point until I reach my stop. So here was my problem the last time. I had 90-degree cuts on the end of my work pieces. When I mounted them to my extrusion, this is an exaggeration now, but I was riding on this edge here, this inside edge. And then once this inside edge was removed, you lose your registration to the table. If you want to take it off and put it back on, you're going to effectively drop your workpiece, whatever your angle is. You're going to that distance between this edge and the table, you're going to lose that. You're going to drop it down on the table that much. So what I decided to do then was cut this angle using these wedges that were the drops from the tabletops. So these two I taped together to make a ramp, and I put those on my miter gauge and cut this angle. So let me do that, and then I'll show you. Let me cut this angle on the table saw over here. I'll get this stuff out of the way. So what I'm going to do is put my workpiece. I know I've got a square corner here, and when I mount it on the ramp, like that, that creates this angle that I need. So the blade's at 90 degrees, the angle's being created by the wedges, and I'm just going to run it through my saw like that. Okay, so now, instead of my workpiece sitting at 90, I've now created that angle I hope you can see that. There's 90, and there's my angle. That's the angle I want for my tenon. Okay, so I'm going to mount what I did then was to take two wedges, carpet tape them to this backer board, making sure that they were perpendicular to the bottom and then parallel to each other up this ramp, or to create this ramp. Now then I've got a 1/4 inch bolt run here through this slot that allows me with the T-nut to connect it to my extrusion. Like so. The one thing that you want to make sure is that that bolt doesn't interfere in this plane with your workpiece. Okay, so that's not a problem. If I was using thinner workpieces, I could have gotten by with just one wedge, but I like the stability of using the two of them, so that now I know when I bolt this, or bolt it, I shouldn't say bolt it, when I clamp this to my setup here after I get everything tightened up, you can see now that I'm flush here to the top. And when I make my cut and I go back to re-register, if I need to pull it out and check my mortise, how to fit into my mortise, I'll always come back to the same point again and not lose anything from my depth of cut, or the length of my workpiece, I should say. I won't lose anything from the length of my workpiece. So if I've got my workpiece cut to length, then I won't lose any dimension off of that by just going off of this corner. If I was doing it at 90, you can see there's a gap on this edge out here. I don't know what it is, but it's there. You know, it's probably a 32nd of an inch maybe. So Got to get it oriented the right way. There we go. So let me tighten things up and then we'll make a cut here and see how things turn out. Okay, got the workpiece clamped. This has been tightened up to the extrusion. It's square this way. You can't, let me, I can't, now that I got my workpiece in there, I can't butt it up tight, but it's square up and down so that I've got my angle set correctly. And then I can now figure out which way I want to register this workpiece to the bit. I've got enough room inside here that I can register off of the back edge, I'll call it, or the front edge. The bit is spinning this way, so what I'm going to do is I'm going to start on this side and push it through, establishing this shoulder cut. I'm not going to really be concerned about the depth of where the Morse is on the workpiece, but let me move this over, get it close here. That's darn close. So I'm going to call that 0. Then what I'm going to do is move my stops up here. Let me see where I'm at. I guess I didn't change anything up there, so I am at 0 up here. Let me raise this up now. Widen this out a bit so you can see everything. Okay, so my dial indicator says 0. My first shoulder cut is 0. I'm going to move it over, I don't know, I'll move it over 200 thousandths and make my first cut. And then we'll see where we're at, and I can make adjustments from there. Let's do this. I'm going to back this up. Give me a kind of a wide shot here of what's going on. And we'll make this cut. Got to change my dust collection setup here. Doesn't do a lot with this, the way this is set up, but it helps. Every little bit helps, I guess. I set that up wrong. I got to pull this into the bit instead of pushing it. I can do it. I can make this back cut if I wanted, but just to be on the safe side, I'm gonna move it back. So I can do that. I'll just go back this way, slide past the bit 200 thousandths. There, and make my cut this way. I know my bit is a 3/8 bit, 375 thousandths. So what I got to do now is move 375 for the bit. So 1, 2, 3. Oh, I got my stop here. 350, 375. Okay, so now my bit is just eyeballing it, and it looks good. This outside edge of the bit is now even with the outside edge of this cut we just made. So I've got to move it again. Now I got to move it, what do we say, 390 thousandths for the width of the tenon. I'm going to come back, sorry. I want to do that on the other cut. So there's 0. So 1, 2, 3, 75. Call that 0. And now move the width of my tenon, which is 390. So 1, 2, 3, 90. And I'm going to make it a little bit fat, just to be sure before I set my stop. I'm going to set it here, but that'll give me that reference point if I have to make any more cuts. Okay, so now I can make this cut. Alright, I didn't have that clamped as tight as I should have. It wanted to dive down on me a little bit, but still pretty good clean cut on both edges. Check the width, and we're tight, just like we thought we would be. Let's see what we got here. We're at 4/16. Can we see that there? 4/15. Somewhere in there. So I got to take off about 20 thousandths, which is about where I was. But now I know that if I put this back in here, I'm going to be registered right back where I was because of that angle I cut before I put it in. Okay, registered flat to the table. That's good. And now I can take off about 20 thousandths, let's call it. Right there. So I'm going to take off 2 more thousandths. There we go. I can make my shoulder cuts. Because I'm just doing a one of here, I don't have to worry about the stops. But if I was doing multiples, I'd set up stops so that my piece would always register in the same position. But all I'm going to do now is make my shoulder cuts. I'm just going to freehand those back and forth here and to get a fit inside of this, or free cut my shoulder cuts on this tenon so that I can fit it into this mortise. So let's. there you see it. Perfect mortise, or perfect tenon into the perfect angle tenon into this mortise. Nice and tight all the way around. And you can see I've got my angle now. So there's my 90 behind it. And I know now that this angle matches my tabletop angle perfectly because of the way it's set up, and I don't even care what the angle is anymore. So that's how that works out. And then now I can set my stops and I can have repeatability to get that kind of joinery just that fast. And I couldn't do that on a table saw, and I'd be hard pressed to do it by hand too. So that's how that setup works out, and I hope you find that useful. I know I do. So if you want to do a setup like this, let me give you a kind of a quick tour here, freehand tour. Okay, so once again, a 40 by 120. I'm guessing it's about 18 inches long or so. Doesn't even need to be that long. A piece of Baltic birch, a 3/4 inch Baltic birch that I've got mounted. I had to create a little rabbet in the birch there. You can see to accept the extrusion right here. There's a little rabbet. That was because I put the UHM W bearing guides on the bottom. Okay. Underneath, then you can see the THK bearing, which is now mounted in the rail, mounted to the extrusion here. Then the bearing, then our piece of 16 by 80, which is mounted to the bearing through these holes. There's two more here that you can't see. That mounts this extrusion perpendicular to that bearing. Okay, then I've got my knob here that gives me the ability to slide this back and forth to the stops. So back to 0. That was my original 0. And then when I put this in here, this would now be my stop for width at this angle. So I can put my pieces back in here and use this for repeatability, just like that, back and forth. And then once I get to a spot, I can lock it down to make sure it's not going to move on me. Okay, my dial indicator with this stop, which is nothing more than just a block mounted that I can take it. I can remove it. It's got a T-nut on the bottom as well. So that's just a friction fit. There's no glue or anything involved with that. My dial indicator mounted to this block, which is also mounted to the extrusion here. I can take this off. So I can position this wherever I want. You can see how that's made. Just a T-nut going through there. The indicator is mounted with a bolt countersunk in there. That can go back on into the slot if I can find the, there we are. Okay, bring it up, whichever way you're using it. If you're moving backward, you want the indicator to just touch. If you're going the other direction, you want to max it out and bring it back a little bit, and then tighten it down. Okay, so this has got to be back here because this is 0. Anyway, that's how it works. Pretty slick setup. Angled or even straight tenons on the router table would be slick on this setup. Get a nice clean cut like this. Good one. Anyway. There you see it. So, thanks for watching.